I'm going to see if I can share my screen now. Yeah, that looks good. Okay. Yeah. So can you see the whole square of image there? Well, rectangle. Okay, cool. So that's Newt. I'm his human, Kris. And we are currently in upstate New York, but I've done surveys in Connecticut, Vermont, Massachusetts, and in a few days we'll be heading down to Rhode Island. Really, New England is this big, so all of those states are like just that big together. But I'm a herpetologist by training. I actually specialize in reptiles and amphibians, and the dogs kind of came secondarily to me because I needed a turtle finding device, and now I have a four-legged turtle finding device. So I'm gonna talk about wetlands. So I say swamps in the title, but I really mean wetlands in general, but colloquially we call all of the wetlands swamps. And I don't know, swamps just sounds friendlier. So I'm going to talk about the different ways that the landscape changes the vegetation that will grow in a wetland, how that's affected both by soil and depth and the water, and then how a wetland ecologist thinks of the landscape with all of that water there. And that then leads into, once we have the vegetation handled, it then leads into the different kinds of wetlands that we have. And I'll end with talking about gear and then disinfection protocols. Disinfection is really important as an ecologist. You need to make sure that you're not transferring disease from one site to another. This is huge in the amphibian world right now, and I've had times where I've walked into a pond, looked down, and all of the tadpoles are floating, and it's like, that's it, I'm done for the day. I have to go home and put some industrial strength bleach on my waders to, okay, that's exaggerating, but I do go home and bleach my waders and sob into my steering wheel when that happens. And we need to make sure that we're not transferring those diseases from one pond to another. Okay, so this is how most of us have been trained to think of a landscape. Here we've got a cross section, we've got sky on top, we've got dirt on the bottom, and big piles of dirt make mountains, and then we've got holes at some point that are either valleys, or if they fill with water, we consider them to be ponds or swamps or wetlands or lakes. And if we blow those up and look at one side of it, we've got this scale where we've got water on one side, we've got land on another. And so we consider the land to be the terrestrial environment, the water to be the aquatic environment. But there's this area in between where the water is not very deep. And that's what we consider to be a wetland. So there's no real good definition that I know of for a wetland. It's just kind of like the land that's wet. So that might be the edge of a river. It might be the vegetated section of a shore of a lake. I tell my students that if you go in the woods and you sit down and your butt gets wet, you're at a wetland. You don't have to see the water for it to be a wetland. If the water's there, it's going to affect what can live there and how it lives there. So right off, we've got whether the water is light or if the water is dark. And if the water is dark, then we consider it to be the limnetic zone as opposed to the littoral zone. And you don't need to know these words, but you might recognize limnetic because limnology is the study of lakes. So when we talk about limnologists, usually they're not considered to be a wetland system if we've got limnology going on. Okay, that sounded more confusing than it had to be. Anyways, the dark area is not going to have any vegetation in it. And if we have a dark area, by definition, we have a lake. If it's freshwater and there's an area that's too dark for plants to grow, it's a lake. If we don't have too dark of an area for plants to grow, it's not a lake, it's a pond. So Lake Ontario is a lake. Lake Okeechobee in Florida is not a lake because Lake Okeechobee does not get deep enough for plants to not grow. How deep it is going to determine how much oxygen is in the air, in the water as well. So we have no plants growing where it's too dark for light to penetrate. But then we get to the area where enough light reaches the bottom for some plants to grow. And they don't get all the way to the surface of the water. So they're underwater. We call these the submergent plants. In the same area, we can have floating vegetation. Floating vegetation tends to be things like lily pads, but also you can have things like duckweed, that's like little tiny leaves floating, water milfoil, which is a little bit larger, kind of looks like cabbage floating. There are some plants that don't even have leaves, they're just little clusters of stem that'll float along the surface. And those can be in the same area as the submergent, but when we get a little bit shallower, we start to get to the area where plants can go above the surface. So these are all emergent plants. So they're not sub underneath, they're they're above the water line. So for this, we think of generally all monocots. So cattails, grasses, sedges, rushes. We also get ferns, some different pond weeds, pickleweed. And a little bit shallower than that, we can get into these shrubs. So if you see emergent wetland, emergent plants, you know that the wetland is not that deep. If you see the floating vegetation, it's probably pretty deep. If you see shrubs, you're right on the edge of the water because the shrub can grow out of the water. It can grow in the edge of the water, but it can't grow very deep. So now if we look at, wrong way. Now if we look at a wetland in an image, we can take some guesses about what that wetland might be like. So this is the part where we've got some audience participation. What do we know about this wetland just off of this image?
I guess it depends if those count as floating plant life, or is that like something that's fallen off a plant that's floating there?
That's a good point. Let's assume those are stems that are floating. Let's treat that as dead vegetation that's just floating there.
So maybe it's not too deep.
Exactly, yeah.
I mean, it's up to the dog's elbows, but yeah.
Yeah. Yeah, Solo gives us a hint. If we look in the background, it looks like there's another pond back there that's all the same floating, the same emergent vegetation too. So it seems to be relatively uniform. Looks like it gets deep pretty quickly to about knee height, but then it stays stable. So it almost forms like an edge and then down and then over again, like a little box. Otherwise, we'd have some shrubs along the edge and the shrubs aren't there. It looks like it gets deep right away. Okay. Then once we get past the shrub area, we get to areas where more terrestrial plants can grow. And this is when the trees start to grow. Normally, you don't see many trees that have their roots underwater. There are exceptions. There are trees that are obligate wetland plants that have to grow in water. But for the most part, when we see a tree, we know that that's the edge. That's probably where the land is, where that tree is. Because they all have roots. Once we stick the roots underneath the water, then we can see how the trees are limited. So this first tree has some roots that go down even with the top of the water, and the tree next to it doesn't. And if we look at all of the plants that are within the wetland, they have some shallow roots too. The roots don't grow very deep underwater, generally for any of the plants, because the surface of the soil at the bottom of the water it's only got a very thin layer of oxygen. Where the mud is, there's a lot of microbes that use up that oxygen very quickly. A lot of the dead material is going to sink and then start to decompose down there, and that's going to take up a lot of oxygen with all the fungus and the bacteria and whatnot chowing down on it. So if you go a couple of feet underneath the surface, a couple of feet underneath the floor of the wetland, there's no oxygen there, so the roots can't grow. So everything has pretty shallow roots. So we need to think about this a little differently than our traditional mindset of hills and water where it dips down. And really, this is something you already know, because if we have a house, then generally we want to have a well so that we can get water. And if we dig down, we're going to hit water. Somewhere there's going to be an aquifer so that we can get water up to water our dogs. And if we connect the well and the pond, it gives us an idea of where the water table is. The water table is just the water that's underground. It's the groundwater, and particularly it's the surface. So if I was to dig my well, the point where I hit water is the top of the water table. I think I wanted to say that. Okay, so where you hit water is the water table. It's the top of the groundwater. And it's not necessarily a flat, so maybe it goes up and down and kind of follows the contours of the surface of the ground here, because we might have some large boulders in there. We might hit bedrock. We might have some shale that's got pockets of water in it. But the ground is full of water. And so once we put that into our diagram, we can get a better idea about why that deciduous tree can grow close to the wetland, but the tree next to it can't. That deciduous tree has some roots that are going down to the groundwater because that's a type of plant. It's a species of plant that is capable of living in that low oxygen environment and having the roots flooded. Whereas this tree next to it, maybe that's a white pine tree. White pines don't grow near water. They can only grow up on a hill because they will suffocate quickly if the roots are flooded. Okay. So that can help us divide up our aquatic ecosystem and our terrestrial ecosystem, which overlaps, because at some point we're going to have plants that are growing on water that can also grow in the water, and that might be underwater sometimes and not the rest of the time. Okay. And also just from the handler's point of view, if I see floating vegetation, I'm going to hesitate to sit my dog in. Because if he's swimming, he's not going to be able to smell as well. He's going to be more concentrating on paddling. He's going to be huffing. And Newt particularly struggles when it's a lot of mucky water that might be sucking to his feet. But if it's a lot of shrubs and maybe some cattails, it's probably safe to send the dog in. It's probably shallow enough that he'll be able to stand and concentrate on what he's doing. Okay. So hydroperiod. This is the next thing that really shapes how the wetland, how the vegetation grows, the ecosystem that's there. Hydroperiod is the period of time that the water is within the wetland. So we have some wetlands that are permanent and they always have water in them. And then we have some that dry up a little bit. Maybe they dry up in August one year when there's a drought, but the next year they don't dry up at all. Or they might dry down to the point that there's so little oxygen in the water that most things that we associate with permanent water can't live there. If I've got a shallow pond and there's no fish in it, I might assume that it's a pond that dries up or dries down to the point that the fish would all run out of oxygen if they were in there. Fish require a lot of oxygen to live compared to amphibians. And then ephemeral wetlands are wetlands that dry up, generally every year. Within ephemeral wetlands, we can break them down into how they fill up and when they fill up. So we might say that something is a vernal pool. California has specific wetlands called vernal pools. The glaciated Northeast has vernal pools. There's an equivalent in the Southeast, but I've never heard anyone call them a vernal pool. If you're from the Southeast, it's the kind of place that gopher frogs and flatwood salamanders would live. Autumnal pools are ones that fill in the fall after being dried up in the summer. And then how the pools fill up, what kind of water fills them up, is going to help to determine the hydro period. If it is an area that gets a lot of snow and then the snow melts all at once in the spring, that water has to go somewhere. It might get to a bowl area and fill that up and become a vernal pool. But also with the groundwater, the water table going up and down, if it's a wet year and we have a lot of water going into the ground, the water table goes up and more of the area is going to be flooded. As the water table goes back down, then we'll have less of the area that's flooded. It takes a lot more time for the groundwater to shift than it does for these snow melts to finish up, to evaporate. So that'll affect our hydro period. And then there's a bunch of little hints within the area too. If we see caddisfly larvae, which are the diptera, the flies, and they make these little houses around themselves. So the larvae are underwater, they look like grubs, but they enclose the rear end in homes made out of decaying leaves or soil, or they'll put sticks together. That tells us that the wetland has to have water for at least 2 months. We've got a mosquito larvae on the top corner there, and they'll breed in like buckets. If you have an upside down bottle cap on your porch, you might get mosquito larvae. So they're not a hint, whereas some of the other insects can be. All right. So here's an example of an ephemeral wetland. This is the same wetland on the left with the water as it is on the right without the water. And there's some hints that would tell me that this is usually a wetland, and that the leaves are kind of a different color. They're kind of they'll either be stained, so they look a little bit more black, or they might be bleached. So in this case, the leaves kind of look white. And that's because they've had a lot of the tannins come out of them. Like when you make a cup of tea and you put the leaves in and all the color goes into the water from those tannins, what you're left over afterwards, if it's just the leaves, it's going to have less of that pigment in it. High water mark. If you have to guess where the water is when this pool floods, you can look for clues along the bank. So in this dry image, we can see where the bushes start, and then we can see where the trees start. So we don't have necessarily a straight indication there, but looking at the image, I've got a pretty good idea about how much of this area is flooded and where the water stops. When you're by a river, generally you can, if you look at a tree, you can see where the water has rushed past it. And there might be a ring of moss there. There might be some discolored bark there. And that's what we call a high water mark. So we'll see some of those in a moment. Okay. So if we go back to our diagram here, and we think about this pond as being either permanent or ephemeral, it's going to change what can live there. So if I take that black high water mark, the water surface, and I move it down here to the red line, and now that's where the water is, most of our plants are going to be fine. So the trees are okay, the shrubs are okay, the emergent plants have a pretty hard, well, is that what I want to say? They have a pretty sturdy stem. It's still flexible, it's still herbaceous, but they have a pretty sturdy stem. So they're going to be fine, but the floating and the emergent vegetation is going to die off. So when I go back and look at this image on the right, I don't see any floating vegetation that's just kind of like on the ground there. I don't see any of the submergent vegetation flopped over. So I know that this site doesn't get that deep. Okay. So here we've got Nooch in California, another turtle dog. And if we zoom in on that wetland in the background, we can look at the plants that are growing in there. So what do we know about this one?
Looks like it has floating vegetation, so it's probably a little deeper.
Yep. What do we know
There
about?
aren't areas with, sorry,
Go ahead.
there aren't areas that like don't have vegetation on them, so it's probably at like a pretty high level for it.
Yep. And also, since there's not areas that don't have vegetation, that tells us it's probably not a lake. It probably doesn't get deep enough that the light doesn't hit the bottom. So it's not going to be like 20 meters deep. So what else do we know?
Looks a lot like a lot of this bordering vegetation is actually in the body of water because it's
Yes.
surrounded by a lot more dead vegetation, which is probably not in the water.
Yeah. So the water that Nooch is standing on, um, the vegetation that he's standing at, that looks like it's dried up grass, which probably doesn't have much moisture to it. But then between him and the open water, there's what looks like reeds. So we've got some grassy vegetation, and it's taller and it's green. So it's likely that that's where the wetland starts. So that's that emergent vegetation. So from looking at this picture, we can see where the wetland starts. We can see that it probably doesn't get too deep, but it's going to be deeper than we want to send the dog all the way into. You're not going to do surveys where you have transects crisscrossing this wetland. You might go around it though. There's a comment that Kayla says in the chat, I guess green veg has wet feet. Yeah. Especially when it's dry out. Okay. So the next thing that we can look at to tell a little bit about the system is the substrate. So the substrate is generally the texture, the composition of the floor of the wetland. So what we would say was the ground in a terrestrial system, we call substrate in a wetland. So it's like, is the bottom of the pond mud? Is the bottom of the pond sand? And it gets determined, again, by oxygen, but also by water flow. The flow is going to play an important part here. So on this illustration, we've got in green the arrow showing what direction the water is flowing. And on one side, we've got fast flowing water. And as it enters into this illustration, it gets slower. And then on the far right, the water is no longer moving. So we've got different sizes of sediment. And if we have fast flowing water, the sediment's going to be churned up. It's going to be within the water column, being moved downstream. And as it starts to slow down, then our larger particles are going to start to fall out first. It continues to slow and our medium particles will fall out, and then eventually the smallest of the particles fall out. And when the water is still, all of that sediment has settled onto the bottom. So when I'm out and I'm looking at a river, if the water is moving fast, I might have a sandy bottom because all of the smaller sediments are being carried away, and sand is the largest of the soil sediments. If it's very slow moving water, it might have a lot of very small particles in it. So it might be a clay surface, or it might just be a bunch of rotting vegetation along the top. Does that make sense? Okay. So here we've got Newt and one of my undergraduate students at a river. They're out looking for turtles. And if we zoom in by her feet, we can see the surface of what would be river when there's a lot of water in it right in the spring. So if this ground was underwater, how fast would the current be moving? Would it be slow? Would it be fast? Kind of medium?
I'll echo what Meg said in the chat that it'd probably be pretty fast water.
Yeah. She says there go only rocks, and that's it exactly. So when this river floods and is at its highest water, that's pretty fast water, and I might not want to send my dog in that in the spring. Okay. Once we start walking in the area, we can use our steps to learn a little bit about the wetland too. So with those microbes that live on the bottom of the pond where that vegetation, where the dead vegetation is sinking to, if they're chowing down on all that dead vegetation, using up all of the oxygen, there's not any oxygen going beneath that to continue with decomposing organic material. So if I step into a pond and my boots don't sink, it means that I'm standing on soil rather than organic material. If I step into a pond and my foot goes beyond what looks like the bottom and it goes down into mud and deeper mud, that's going to be some of that organic material with that fine sediments. And that gives me an idea of, is the wetland temporary or is the wetland always flooded? And I'm kind of skipping around on this slide. And I should probably go in order. Okay, so dries up, we're going to have soil. You're going to be able to walk on it. And the reason it's soil is because when the pond is dried up and all of that leaf litter, organic material is exposed to the air, it burns off. Like if you just leave leaves out in the open long enough, the microbes are just going to consume them. They're going to take the sugars that's within the cellulose, break it down, and they exhale it as carbon dioxide. Same as when we eat sugar and we exhale it as carbon dioxide, and there won't be anything left eventually. So it's just the soil with no organic material. So it might be like a yellow sand. It might be more of a loam that's going to have some color to it, and it's going to be easy to walk on. If the area stays wet, we have what we call muck. Very scientific term there. And muck is sticky mud that's got a lot of organic material in it. It tends to be very dark in color. It tends to suck onto your boots as you're walking. So if you see somebody who's trying to cross a puddle and their boots get stuck, it's muck. It's a wet area that doesn't dry up. Oh, and it can release swamp gas. So when we think about methane in swamps, it is released by microbes that don't have access to oxygen. So they're producing methane rather than producing carbon dioxide, and it gets trapped in there. And sometimes you walk in and you disturb all that sediment and all these bubbles rise around you, and then it smells bad. Kris, what makes yellow sand? Comment in the chat. You know, I don't know. It's probably a mineral thing with iron in there, but I say yellow just because most of the sand in my area is yellow, but we do have other color sands. Megan says okay. All right. So let's look at this river. I'm gonna start with one question, then I'm gonna zoom in and I'm gonna ask you other questions. So how high up does the water get here?
Well, it looks like there's a water line by that tree.
Yeah.
Yeah, I would guess the ferns don't have wet feet like over by your student's knee up above there, but it looks like everything below that is below water line.
What do the shrubs tell you?
It looks like there's a bank right under them, kind of up at like waiter line height, chest waiter height.
Yeah, like right in front of where her chest is. So the tree is right. The tree is telling you where the high water line is. So where you see the roots come together about even with the ferns, that is a high water mark. And the shrubs can have wet roots, but they don't need to have wet roots. So they're right along the edge there. We don't see a lot of trees in this area, and that fits with the water table being pretty high here. So let's look at Newt's feet here. So he's running along, he's sinking, and he's getting covered in dark colored bud. So let's see. How fast is the water when this section of the river is flooded? And then does this entirely dry out or does it stay wet?
Looks like a slow current that doesn't dry out.
Exactly. Why?
When the substrate is underwater, the current is slow because the mud has gotten really thick and mucky, and then it doesn't dry out. Well, kind of for the same reason, right?
Yeah.
Oh no, because it's going to be silty material.
Right.
So that's why it's not. I'm sorry, I got those switched. Yeah.
Yeah, I see what you're trying to say. So it must be going slow because small particles have fallen out. And it must not dry out because we've got organic material that's making it look dark and that's making it sticky. And Madison, you're so much braver than everyone else. All right. So with that, now we can actually get into looking at what kind of categories of wetlands we have. When we say swamp, what we technically mean is that we've got an area of wetland that has trees growing in it. So this is a swamp. This is also an ephemeral wetland. It's relatively shallow. We were looking for little tiny shrimp in the end of winter in this one. But the dominant vegetation in here, the vegetation that covers the most area, is the trees. So this is technically a swamp. We also have shrub swamps, which tend to be a little bit deeper. Shrub swamps are usually knee deep to about 4 feet, meter and almost a half. It's like armpit height for me. So just above where my waders would be. So I wind up flooding. And shrub swamps are generally deeper because shrubs can grow deeper. And shrub swamps are a real good system to send a dog into. The swamp is fairly open so we can see well, but when you get a shrub swamp, it's hard for us to see and it's hard for us to move around. But there's generally a pocket of open area right at dog level. Okay. Marshes are dominated by grass. So grasses, sedges, rushes, which are closely related and they all kind of look the same. Okay, and then floodplains. Floodplains, I don't have a good, well, I have a lot of pictures of floodplains, but it's easier to think of more in diagrams again. So on the left, we've got the normal water level of this river that's coming straight towards us. And then on the right, it's high water. So maybe we just had a really big storm go through and it's flooded this system. So now the flat area on either side of the river is underwater. And that's actually what makes it flat, is the water flowing over the surface. And then beyond the floodplain, we've got some hills that go up and that'll contain the flooded river. Floodplains tend to be a real good place to look for amphibians because the water table is relatively high underneath them. Okay. So what do I have? Where is the floodplain?
I would say kind of where your student and the dog is sitting, because to the right, I don't know, it might go to the right too, but it almost looks like it's uphill on like the right bank of the river there. So
Yeah, exactly. We got a lot more trees on the right bank. It looks a little steeper, but it's nice and flat with like not a lot of trees growing where the student is sitting. This rock in the foreground, if you look at it, there's an area on the bottom that has moss, and then there's like a naked area, and then there's a stripe of moss. That stripe is our high water mark here, because in the springtime, the water that was flowing by, any vegetation and sticks that were being carried down river scraped against that rock and removed the moss that's underneath that stripe. Okay. Bogs and fens. These tend to start as a bowl and they fill in with vegetation. They have very acidic water, and vegetation doesn't decompose well in acid, so it winds up preserving it. And then it fills in with plants that can grow in acidic water, which pretty much means moss. And bogs are a lot of fun to play on if you know they're safe. Because you can walk onto it and it's like walking on a water mattress. You kind of sink and bob up and down. On the other hand, if you fall through the moss, you take the wrong step and you wind up going through, you wind up drowning, and then in 200 years, somebody can find your perfectly preserved body. So be careful on bogs. I wouldn't do a bog off leash. Use a long line for a bog. And then open water is the term that we have just for water that doesn't have any vegetation in it. So here we've got a vernal pond, and we've got ice in the background. That's why it's white there. And then we've got an area with very little vegetation. So that's what makes this a pond. We've got light hitting the bottom, but it's open water. So even though this only gets to be maybe half a meter deep, it's still considered a pond. And then it dries up, and I had a logger who was trying to stack his logs in the middle of my pond, and I was like, no, my salamanders. And he was like, oh, okay. Loggers can be nice. Developers tend to yell at me, but the loggers tend to be nice. Okay. So what do we know about this one? Let's back up. Which of these plants is not underwater? Or doesn't have roots underwater? Yeah. Which of these plants don't have roots underwater?
The trees.
Yeah.
The trees.
So that's the edge of the water, the wetland.
This is so good.
Say that again. Okay, so we've got some floating vegetation in the middle. So that's going to be relatively deep compared to where the cattails are. And if we have floating vegetation, is this going to be temporary water or is this going to be permanent water?
Permanent.
Right.
Since it's floating and it can't be sustained when there's no water.
Yep. So it doesn't look deep with this person standing in the middle of it, but it's permanent water and it looks pretty dark. So that tells us that the substrate is going to be very sticky. So would you want to send your dog into the middle of this?
Probably not.
Probably not. Okay. I've got some other ones that I'll go through just slowly so that you can come back to the presentation and practice if you want. But it's 8:45 and I want to get to the end so that we can have a few minutes to have more of a normal discussion. Oh, actually, this is a good one. All right, so we've got a bunch of dead trees and we've got a border collie on a log. What do we know about this wetland? And in this one, you have to kind of like think about why are the trees dead?
Has it possibly experienced flooding that it's not accustomed to?
Yes. So this is a beaver pond. So the trees grew when it wasn't very deep, and then it became deep, and when it became deep, it killed the trees. Beaver ponds, you tend to have a lot of horizontal logs floating in the water, and that can make it dangerous for you to walk through because you might not be able to see your feet and you might not be able to see where there are sharp sticks pointing at you or what you might get caught on or what you might trip on. So the people that I know who have gotten stuck in a wetland and had to call like their wives or someone to come and get them, to rescue them, it's always been in a beaver pond. So maybe you can send the dog into this one, but you want to be careful going in yourself. And more swamps. Okay. So things that I put in my pack that I wouldn't necessarily in a terrestrial system. When you go into water, if you have a terrestrial collar on or any kind of flea and tick water, a lot of that pesticide gets put straight into the water. So terrestrial collars, they lose, I don't remember the number now that I'm trying to bring it up. It's either like 60% or 90% of the usefulness gets washed away if you send the dog into the river. And so that's an expensive collar to just rinse off. The other thing is that, they're meant to kill invertebrates, but as conservationists, we want to have healthy populations of invertebrates. Permethrin is the same thing. Permethrin rinses off. So even if you have clothes from the factory that have permethrin worked into them, it's not going to shed the permethrin as quickly, but it is going to shed some of the permethrin. So I wouldn't put a jacket soaked in permethrin on my dog and then send him into a wetland because I'm going to be, again, poisoning the wildlife that lives there and wasting the usefulness of the gear. I do tend to put neoprene or canvas vest on my dog because he tends to impale himself. So I'm not putting it on there to necessarily keep him warm. I'm putting him on there to kind of like shield him a little bit. I tend not to use leashes when I'm out in the swamps, but sometimes you have to. Shed blade towel shampoo. The shed blade often, they look like this thing in the middle here. Got a handle on it and a metal ball and there's teeth pointing down. If you flip it over, it's smooth. So if you use the shed blade on a wet dog, it pulls all of the water off of them quickly. It makes your dog dry like 10 times faster. So before they hop up in the trunk of your, up in your car, truck is the word I'm looking for, just clear them off with the shed blade and that'll be good. You'll have a drier dog. Shampoo, because again, for wildlife diseases, each time that my dog finishes a transect, I have to wash him before I can take him to another river. So for us, We want to have something on our head generally, unless you have very short hair, because when you are going through a shrub swamp, or if you are walking through some tall emergent vegetation, generally it's going to stick into your hair and it's going to break off and you can get tangled and it's just a mess. So it's easier to just have a bandana or something. Your shirt, you want to be long enough to cover the top of your waders if you're wearing hip waders, because as you're walking through this vegetation and all those little pieces are falling off, they're going down and they can wind up inside your boots. So if you can have something bulky above your boots, you wind up being less of a, I want to say, not tumbleweed, bag full of decomposing sticks. For boots and for waders, you want to have something with a hard sole. So here we've got a normal rubber sole matched with this pair of chest waders, and it's really easy to decontaminate. There's other waders that are meant for fly fishermen who might spend a week at the same place or might go to the same few fishing holes over and over again. And they might have neoprene booties that they then put inside of wading boots, or they might have felt soles. The felt soles make it so that they're less slippery if they're walking on a lot of algae covered rocks. You can't disinfect those. You can soak them in bleach overnight. You're still going to have rhinovirus or potentially different fungus within the soles of those boots. So for conservation work, it really has to be something that you can decontaminate easily. Thrush, scrub, bleach, spray bottle. Your spray bottle is to put bleach in, so 10% bleach and 90% water, and then you can just mist down the waders in between the different sites. You need to allow the waders to dry before you go into the next site. So that usually takes about 20 minutes. You get out, you scrub the mud off, you spray them down, and then by the time you drive to your next site, you're probably ready to go. When you get started walking in wetlands, you might want to bring a walking stick, because if the mud is sticking to your boots, you can get really stuck. When you're walking through sticky vegetation, sticky substrate, usually it helps if there's a bunch of branches down. If you step on a branch and that pushes down, it's going to be like snowshoes. You won't sink as much. And in certain times of the month, menstrual cups are very helpful, because if you've got water that's up to your hips and you flood, you don't want to be wearing a sanitary napkin because you're just going to be covered in your own blood inside of your waders. And if you use tampons, then you have to keep going to shore to change them anyways. So the cups tend to give you a longer amount of time that you can be in the swamp. But then all the men in the crew don't stare at you and think, geez, she has to pee all the time. And I've had that happen, and I looked at him and I'm like, well, I have ovaries. And then they shut up. Okay. Polarized glasses are good. Polarized glasses let you see through glare, so that you can see a lot more of what's under the surface of the water than you would with like normal sunglasses. Light in the Rain is my favorite type of waterproof paper, though there are others. Pencils are good because they float. And when pencils get wet, they still write. When you're in a shrub swamp, it's really easy to get turned around. And it's really easy to flood all of your electronic devices so they don't work. So always have like a laminated map, or a map that's printed on waterproof paper, and a compass, so that you know that you're walking towards the shore and not deeper and deeper into the swamp. And pocket knives are good for when you do get your waders caught on something and need to like not drown. Oh, okay. NEPARC, Northeast Partners Amphibian and Reptile Conservation, have a really nice, short and simple decontamination protocol on the website. It's a pamphlet that you can print out and keep in your truck. And it talks a little bit about the diseases that that we amphibian people are completely afraid of, and tells you what to buy and how to do it. Okay. So I'm going to stop sharing. Okay, and now you are just stuck with my resting bitch face looking at the screen because that's what tends to happen. So, questions, concerns, stories? Your turn to talk.
I'm thoroughly confused about the definition of bog and fen because we've worked in bogs and fens, or what I thought were bogs and fens, but they were not what you described. Like we didn't have to. That sounds more like a pond. So like, what?
Okay.
Like where does a bog turtle live? I thought they lived in bogs, and aren't they like they hang on like the little tussock mounds and
That they do.
you know. So
bogs can vary in depth, and the ones that have the like waterbed effect, those are like the superlatives of the bogs. Really, you can have a bog that's only like 6 inches deep. So wherever you've got a little bowl in the landscape and the water becomes acidic, then you can start getting the moss accumulating, and that'll be a bog. The further north you go in North America, the more bogs you get. So bogs are particularly common in New Brunswick, northern Nova Scotia, northern Maine. They start getting more of them. If you go over to Europe, they tend to be a northern thing as well. And bog turtles actually live in fens, but if you go back 100 years, nobody knows what a fen is. A bog doesn't have an inlet or an outlet, so it's only rainwater. A fen has a stream feeding into it and then flowing out with it. So it's a very nuanced definition.
Yeah, most of ours around here are calcareous fens.
Yeah.
Which I think are like, I don't know. I feel like they have peat. There's something to do with peat. Not my dog Pete, but the actual the actual peat.
So peat is sphagnum moss that hasn't fully decayed yet, so it starts to break down, but then generally the new moss just grows on top of the old moss, and then new moss grows on that. And the moss can burn off, so if, yes, I know, I'm almost done, you stay. If you have a bog and you start draining the water, then all of the peat is now exposed to the air and it starts to decompose and then it shrinks. So it's a major factor in climate change. My old dog is trying to stand up and she can't. Hi, Denny.
Sorry, then I only have one more comment, and that is that like just laughing at the photo of barley, because like I feel like here where I'm at in the Northeast, like I always see dead trees around wetlands, and I'm never sure whether it's because there's it's a beaver situation or if it's just because they're all ash because all our ash are dead. So I was like, oh, it's because they're ash trees, and then I was like, oh wait, no.
Yeah.
She's in Alaska, they're not ash trees.
Yeah. Emerald ash borer is like one town away from me, so I'm like trying to find someone with a chainsaw to come out and take down my ash trees before they lose the value as firewood. Dead trees produce less heat than trees that were alive when they got cut down.
Oh.
So,
wow.
Yeah.
Paul says, do you have canine decontamination protocol between ponds? I'm assuming he's asking like beyond the shampoo that you mentioned.
Yeah. If you are staying relatively close to the same location, I might not worry about it. So if you're at one site and you're going maybe, let's say 500 meters from one site to another, then bleach your waders, but there's not too much you can do about the dog. If the dog's wearing a vest or boots or something, you can bleach those. But you don't really have time to shampoo the dog. So My sites, I tend to just wash him once a day, but I also tend to be in the same river or the same wetland system. So that's something that I think as a community, we can probably start to work out is like, what is the best way to keep our dogs from spreading diseases from one site to another? I don't have a good answer.
I'm unfortunately going to be this is more of a comment than a question person. But we've also found like weight bearing harnesses. We use the Roughwear harness that's got the handle on the back. Really, really helpful for our muskeg work. We haven't had to fish barley out of too many things yet. But instead of having a leash, it's been nice to just be able to grab them by that like handle, and it's, you know, a little more ergonomic for everyone.
Yeah, that makes a lot of sense.
Yeah, I don't know how I ever ran a dog not wearing a weight bearing harness before.
Does he ever get like caught up in things? Like if you, I know you've got a lot of
Yeah.
trees.
No, shockingly, no. He did
Hmm.
in Guatemala. But the veg here doesn't seem to grab him nearly as much. We get stuck, but not him.
Cool.
Kris, what do you think about like what's if you didn't do the decontamination protocol at all, like for your boots or your dog's gear or whatever, like how many days if it of it just like being dried out, like does it take for it to not be an issue anymore?
It depends on the disease. So Kitcher disease, BD, which has been the disease that's killed off a lot of the amphibians in Australia and Central America. As soon as that dries, it dies. So if BD is the main concern, then you just have, like, you can have multiple pairs of waders, or you
Yeah.
can have multiple vests for the dog. But things like rhinovirus will stay active potentially for, I think off the top of my head, for like months at a time. There are ponds that dry up and then get wet again a year later and still have rhinovirus in them. But that might be more of a, there might be some other host there that's allowing it to continue. And top
Do
of
you
that,
ever have multiple?
go ahead.
Oh, I'm sorry. Go ahead.
We've got other diseases that are emerging too that we don't know much about. So there's a snake fungal disease that's relatively new. There's rhinoviruses that affect turtles. There's got to be things that affect, you know, birds and ducks and different invasive insects that you can bring from place to place too. So be as careful as you can. And you can't be perfect, but make an effort, and that's better than nothing.
That comment made me think. I wonder if do you ever have multiple of like we know this area is contaminated, so you're going to be wearing your really like likely contaminated gear even as much as we try to treat it, and then when you go to a pristine area wearing your cleaner version of the gear, like for the dogs that you for the gear that's it's fabric based and maybe doesn't get as decontaminated.
If I have an area that I know is already kind of risky, I might just save it for last in the day. So that I know that once my equipment has that water on it, I have more time before I take it into another area. But I don't think I necessarily have like different materials for that site than others. Because let's say I've got one type of virus on it, but it's another virus that's in the site, or it's another strain of the same virus, then the wildlife there is already like unhealthy, and the immune system is more stressed already. So if I take my other version of that virus in, then it can be double whammy. But I also just tend to buy like multiple things at once if I know I'm going to need multiple pairs of waders throughout the season. That's another thing about neoprene. Like, if you keep bleaching it, it tends to start to fall apart, which is not a big deal if it's a dog vest because your dog is already wet, but it's a big deal if it's your feet, because the difference between wet socks and dry socks is emotionally, that's a huge difference.
Huge. You are correct.
Yeah, I'm sitting here barefoot because I walked in from a muskeg and sat down for this meeting right away. I'm not changing my other clothes, but the socks are coming off.
I carry multiple pairs of socks in my vehicle.
That's so smart.
This is a really lame practical question. It is really hard to find waders, especially in Australia, that fit me. So this is a general question for everyone. Where do you find waders that fit small women? I will special order them, but I need some.
If you have a big box store type of outdoor store, go to the little boys section. That's I think.
Okay, that is kind of genius. Let's order them from the boys section at like Bass Pro or something.
Yeah, that's actually
We
that's
don't
actually
have
brilliant.
that,
Honey, you gotta stop, girl. Okay, old dog locked in with husband, young dog tearing up the kitchen. Husband giving me the like, what the hell, he escaped face.
Yeah, so Kris, I just have one more question that is like, why is newt so weird and will work in swamps but won't get rained on? So yeah, that's my question.
Why is newt so weird? That's like a book. He doesn't have an undercoat for a Labrador, and rain tends to be colder than groundwater. But maybe it's just something in his little newt brain. He's a little neurodivergent. That's okay. The rest of us are too. So I don't have a good email address right now because I am switching jobs, but I am on Facebook relatively regularly, and I'm on the Slack page at least once a week. So if you think of questions later, or if you have a story you want to share with everyone else, you can look for posts there, and I will get back to you.
Well, thank you so much for your time, Kris.
Yeah. Thanks for letting me walk off on talk about swamps.
Oh my gosh, no, thank you, Kris. This was great.
Okay, good. I wasn't really sure if this was like too much off the deep end.
No, thank you. I'm thinking about survey areas in different ways. It's like you can see into the future, into the past with what you've taught us. So thank you.
It was amazing, Kris. I loved it. Like a masterclass in wetlands. I had so much fun.
All right, now the rest of you need to sign up. Otherwise, I'm going to keep it'll be wetlands part 2, and we'll talk about maps.
Okay, bye.
Don't threaten us with a good time.
I think someone needs to stop recording.